For those of you who might be battling with the maths of the Keynesian model, this video is for you. We're going to start off by having a look at the simple Keynesian model. You can recall that in a simple Keynesian model, we've just got consumption and investment. So we're ignoring the effect of government and net exports on aggregate demand for now. So aggregate demand, we can further decompose this into autonomous consumption. Consumption is equal to an autonomous component and an induced component. The part that's independent of income and the part that depends on income. And we can assume that investment too, to begin with, is also autonomous or independent of income. So I'm going to put a little tick over those terms with the bar, and we're going to call that total autonomous spending, C bar plus R bar, total autonomous spending in the economy, plus the induced component, and we get an expression for aggregate demand. Recall that in equilibrium, aggregate demand is equal to income. Aggregate planned expenditure equals income or output. So we can put income equal to aggregate demand, and we can solve further, taking like terms across. We get y minus little cy equal to total autonomous spending. Simplify, that's y into 1 minus c is equal to a bar. Now we've got to divide both sides by 1 minus c to get rid of it. So you get y is equal to, dividing by 1 minus c, get rid of it that side. You've got to divide the other side by 1 minus c. Or, how we typically express this is equilibrium income. Remember, we've got equilibrium. Equilibrium income is equal to 1 over 1 minus c times by total autonomous spending. And this is an important expression. It's one that you should recall and know. This part here is the multiplier. Okay, so it's showing you how total equilibrium income is related to multiplier times by the total level of autonomous spending. So this gives you a level of equilibrium income. So say, for instance, autonomous consumption is 100 million in your economy and investments 100 million. Total of those together is 200 million. You can then times that by your multiplier. In this instance, our multiplier will be equal to 1 minus, let's say little c is 0.8. Okay, let's take a marginal propensity consumer of 0.8. 1 over 1 minus 0.8. 1 over 0.2 or 5 in our example. Okay, so our multiplier is 5. And we said that C was 100, C bar, bar was 100, so you get 200. So 200 would be total autonomous spending multiplied by your multiplier of 5. 200 by 5, you get a total level of equilibrium income of 1,000. You can also transform this equation by taking deltas. You can say change in y is equal to your multiplier times by the change in autonomous spending. So you can adapt it. And let's take an example there of that. Is if, for instance, investment, autonomous investment, were to rise by, say, there's an increase in autonomous investment by 100 million. Okay, so let's take, this is 100 million. This rises by 100 million. Multiplied by your multiplier of 5. And your change in income is going to be 500 million. So you can see that your initial change in investment is multiplied by your magic multiplier to get an even greater proportional change in income or output for this economy. Let's see how this looks if we plot it. Okay. Recall what you've got on your axes. You've got income or output on your horizontal axis, aggregate demand or aggregate planned expenditure on your vertical axis. So you're going to draw an aggregate demand curve. It's upward sloping. Call it AD0. And your initial intercept is going to be A bar. So where this aggregate demand intersects your 45-degree line. Remember, your 45-degree line from the origin is the point. It gives you points of reference. It's all points at which whatever's on your vertical axis equals what's on your horizontal. So all points at which aggregate demand equals income. Just move this down so you can see it. All points at which aggregate demand equals income. So where this aggregate demand curve intersects your 45-degree line is where you're going to have your initial equilibrium and level of income, y0. So you're in equilibrium there. Now what happens, as we said, if autonomous investment increases by 100 million, what's going to happen to income? Well, our aggregate demand curve is going to shift up parallel. Let's draw a new aggregate demand curve. Shifts up parallel. And we're going to give a new intercept. We'll call it A bar with the subscript 1. That's going to increase by the change in whatever component of autonomous spending is changed. Here it was our investment that was changing, R bar. Where this new AD curve intersects your 45-degree line is where your new equilibrium is going to be, called Y1, equilibrium E1. And if you draw it, I haven't quite drawn this to scale here, but if you drew it to scale, you'd see that the change in income would exceed this change in autonomous spending here, change in investment. Why? Because of the working of the multiplier. The change in income is greater than the initial change in autonomous spending because of the presence of, because of the effect rather of the multiplier. Okay, so you can relate this to your diagram. Recall that A bar, your intercept of your aggregate demand curve, gives you, here it is, your aggregate demand curve. This is your intercept. It shows you when Y is 0, what's the total level of autonomous spending. It consists here just of C bar and R bar. Okay, that gives you A. The slope of your aggregate demand curve is given by little c, your marginal propensity to consume. Now we want to look at what happens when we introduce government, and particularly we introduce government with a proportional tax. How does this change aggregate demand? The aggregate demand now is equal to C plus I. Now we're introducing government, putting it back in, and net exports. So, first of all, we decompose consumption. We get the autonomous component and the induced component, the part that depends on income. However, and this is where you would start, is you don't have to remember the whole expression, but if you just remember how to start, that aggregate demand is equal to C plus I plus G plus NX, and you substitute in the presence of government for income, you substitute in that you've got to subtract from income the taxes that people pay and add any transfer payments or grants, etc., the government may pay. And this gives you a kind of an idea of net income. And it's that out of which people consume. So they don't just go and consume out of gross income. You take your gross income, you've got to subtract the taxes you owe, add the transfer payments that you receive, and you will consume a proportion of that. Okay, so that's how government alters consumption, by these two effects, by taxes and transfer payments. So just recall this, and if you substitute in, and then you just simplify, and you can carry on adding the other terms. R still assumed to be autonomous, R bar. Government spending enters in as an autonomous component, independent of income. Just add net exports. And then it's just a case of simplifying, multiplying out and simplifying. You've got C bar plus, simplifying these brackets, plus little cy. Positive by negative, you get negative little c ty. Okay, and you multiply this out, you're going to get plus ctr plus I, autonomous investment, plus government spending, plus net exports. Okay, so you can see the three effects of government: by government spending, by transfer payments, and it affects your taxes. Okay, and you're going to see that the effect of what the tax does is to reduce the marginal propensity to consume. We're going to see that now. Right, we can then simplify this. Just gather all your like terms, all the autonomous components, those with the bar, and we'll call that total autonomous spending for your economy. And then this part here that involves Y is your induced component. And if you simplify this, if you take C out, you get C into 1 minus T Y. Okay, you get an expression for your aggregate demand. What's the difference? Recall that in a simple Keynesian model, we found that aggregate demand simply consisted of autonomous spending plus little cy. So what is the introduction of a proportional tax done? A proportional tax would be something like you could have little t of 0.25, proportional tax of say 25%. What is this little t done? The only difference between this and what we've got now for aggregate demand is that C is reduced by the presence of the tax, by 1 minus T. The marginal propensity to consume has been reduced by this term, by 1 minus T. That should make sense that when there's a proportional tax, it reduces the amount of income that's at your disposal to consume out of. So once again, we can recall that aggregate demand in equilibrium is equal to income. So we can put this whole expression equal to income, and we can solve. And we did that before, so I'm not going to go through the maths of that because you could do it on your own. But if you alternatively, you can just remember the expression, which is for equilibrium, which is this. And you will see that this is, once again, this is very important and you should recall it. So what difference has the introduction of the proportional tax made? You can see the proportional tax has influenced this component, the multiplier, we call it the government multiplier, the multiplier in the presence of a government with a proportional tax. In your simple model, remember that an equilibrium income was equal to 1 over 1 minus C times total autonomous spending. So you can compare the difference. The multiplier is altered by this 1 minus T because C was reduced by the presence of the proportional tax. And you're going to see that by including this here, it reduces the multiplier. Remember that if we had in our example, we had a marginal propensity to consume of 0.8. So we found our multiplier was 1 over 1 minus 0.8, which is 1 over 0.2 or 5. So that was our multiplier previously. What's our multiplier going to be now? Still assuming that the marginal propensity to consume is 0.8. And let's take a little t or tax rate of 0.25. Let's see what that does. Okay, so substituting in, we're going to get 1 over 1 minus, C is going to be 0.8. In brackets, we're going to have 1 minus 0.25. Okay, let's just solve first, before we do equilibrium, let's just solve first for this multiplier. Okay, step 1, you recall from your maths, is that you simplify your brackets. You simplify 1 minus 0.25 and you're going to get 0.75. Okay, always do the brackets first. Step 2 is to multiply your answer from step 1, the 0.75, by 0.8. So 0.75 by 0.8, and you're going to get an answer. You're going to get 0.8 by 0.75, and your answer is going to be 0.6. Right, so simplified the brackets, got 0.75, multiplied that by 0.8, and we get 0.6. So what do we do next? Step 3 is to take 1 minus your answer 2 in step 2, 1 minus 0.6, and that's going to give you 0.4. And then the very final step is to take the inverse of that, because remember you've got 1 over that. Inverse of 0.4, 1 over 0.4, and your answer is going to be 2.5. So your multiplier here is 2.5. So how's it changed? So this is with a proportional tax, a multiplier with a proportional tax is 2.5. This is the simple multiplier. The simple multiplier was 5. So the presence of the tax has slashed your multiplier in half in this instance, from 5 to 2.5. And you can transform this, take a change in y, and you take your multiplier here, it's 2.5 times the change in component of autonomous spending, and see how that affects income. So for instance, say investment rises by 100 million times by 2.5, you're going to get 250 million. As opposed to the change we saw earlier, where we had change in you had a change in autonomous spending of 100 million times the multiplier was 5, you got a change of 500 million. So you can see that smaller multiplier means a smaller effect on income. So you may ask yourself, you may think, oh, that's not necessarily a good thing, because you're going to get a smaller change in income as a result of this proportional tax due to a smaller multiplier. Well, what government's trying to do, remember a proportional tax is like an automatic stabilizer. Government's trying to reduce these radical swings away from your trend of output growth for the economy. So if, for instance, investment were to fall by, say, 100 million, times it by 2.5, you're going to get a 250 million fall in income. So you don't want that fall to be too great. So that's an example of where you would want to reduce the multiplier to reduce the extent of that depression. Another way that government can affect the economy and stabilizes it through transfer payments, and also through unemployment benefits. So for example, if economy moves into a slump, into a recession, it can make greater unemployment benefits available, and that can prevent the extent of that downturn in the economy. So those are in place. So you don't have to use case by case example and go and decide what you're going to do. Your proportional tax is automatically going to adjust things. Please recall too that the only autonomous term that enters indifferently into A bar here, you can see you've got C bar, CTR, I, G, and NX. The only one that enters in differently is transfer payments. Please note that they enter in with little c in front of it. So if you want to have a look at how transfer payments is going to affect income, remember to multiply your change in transfer payments by little c in order to get the correct answer. I hope that this helps you with your maths and that you'll have found it useful.